Internationalization, typically abbreviated as I-18N, is the process of designing an application so that it can be adapted to various languages and regions. Adding support for more languages, currencies, etc. shouldn't require project implementation tweaks, and depending on the implementation, whether we load translations statically or dynamically, we should be able to modify translations on the fly. What that means is textual elements such as status messages, error messages, etc. should not be hard-coded, but instead pulled from a specific translation file or source relevant to a user's region. This allows for an incredibly flexible system where a user can ask for something in a certain language, currency, etc., and get it returned back to them in that format. Now, when it comes to internationalization, there are a lot of libraries we could use in our apps. I18N, I18Next, SJS-I18N, etc. And whether you choose one of those or just decide to implement something on your own really depends on what complex features your app requires and, of course, how much time you have. In this lesson, we'll implement a very basic mechanism by ourselves, just to avoid pulling another library and making our application prone to potential breaking changes that could be introduced by third-party packages in the future. However, to make our lives at least a little bit easier and focus on the task at hand, we'll be installing two utility packages. The first being Accept Language Parser, which parses the accept language header from an HTTP request and produces an array of language objects sorted by quality. And String Format, which is a small JavaScript library for formatting strings that accepts named properties. Alright, so let's head over to our IDE, open up our terminals, and install both these packages. Once everything's installed, let's generate a new I18N module using the Nest.js CLI. Also, let's generate a corresponding service. Let's open up this newly generated module and start by making sure we export that new I18N service so that it's available to our other providers. Next up in the source directory, let's create an assets folder, and inside of this folder, another directory called locales. In this folder, we'll create two files. en.json for our default language, which will be English, and pl.json for another language, Polish. Inside both files, let's paste the following content. In the en.json file, hello, hello, and in the pl.json file, hello, cześć. So as we can see, we have two translations so far, and each translation file contains one key, which is hello. This is just for demonstration purposes, of course, but if you're new to internationalization, in these files you would have all of your key values for everything you need translated in your system. As we mentioned earlier, these could be specific success error messages, prompts, general API responses, anything and everything that would be important for you to have translated. Let's also make sure we update our tsconfig JSON file, setting resolve JSON module to true, which lets us import JSON modules from within TypeScript modules. Now onto our I18N service. Let's start by adding 3 imports. Note that alongside the 2 language-specific imports you might see, English and Polish in our case, we also have one additional type-only import that indicates that we'll treat our en.json schema as the main schema for all the other languages and translations, since we'll be making it our default locale for our application. Also note that in our case here, we're statically importing all the languages, so the more languages we would have, the more imports we'd have to add here. However, if we wanted to load all languages dynamically, we could just iterate through files located in the locales folder. Check out the corresponding code in the description of this video for how that could be achieved if you're interested. Inside the I18N service class, let's declare 3 properties. Static default language, which is pretty self-descriptive, we'll make it equal to EN, or English in our case. Static supported languages, which is an array that represents all the supported languages by our application. And a local private locales object, which holds all the actual translations. With all this in place, let's now declare the translate method next, and let's break it down. This translate method takes a single input argument, which is a key, under which each translation provides the appropriate string and returns a string. Our translations only have one key so far, which is hello, but this would work just the same if we had 10,000 keys there as well. Inside of this method, we retrieve the corresponding text for any given key. But how can we get the current user's locale in this method? This is where request scope providers, and especially durable providers, come in handy. So let's first flag this class as request scoped, passing scope.request to the injectable decorator, and also let's set it to durable true. With this in place, we can now inject our durable DI subtree payload using the inject request instruction. Here we can expect that the payload will be an object with a single property, locale code, which represents the user's locale. And with this dependency injected into our class's constructor, we can now use it in the translate method to retrieve a user's locale, removing the to-do comment we had here and replacing it with the following code. Last but not least, we must implement our custom context ID strategy to actually register per locale DI subtrees. For this, let's create a new file in the core directory alongside the strategy we created in the previous lesson and call it aggregate by locale strategy. Inside this file, let's paste what we implemented in the previous lesson, replacing the tenant word with locale. Now, aside from the boilerplate code that's almost identical, there are a few other things we will need to change here. First, let's replace every occurrence of locale ID with locale code, just to make things more self-descriptive. And also, let's make sure our payload matches the interface we expect it to be inside the I18N service. Next, instead of using the xLocale ID header, let's retrieve the locale information from the accept language header using the pick function from the accept language parser package we installed in the beginning of this lesson. Also, in case locale code is null, we can fall back to our default language. We can also remove the condition below since locale code will never be null or undefined. With this in place, let's make sure we replace the context ID strategy we applied in the previous lesson with the new one we built in this chapter. So for this, let's navigate to the app module file and change the aggregate by tenant context ID strategy to aggregate by locale context ID strategy. Great. And now, before we test everything out, we have to actually use the I18N service somewhere. Let's open up our app service file and start by first injecting the I18N service inside of it using the standard approach. Note that this will make our app service and app controller implicitly durable as well, so always keep that in mind. Inside the getHello method, let's use the I18N service translate method. When typing things inside of the translate method, we can see that we have things strongly typed here. Since hello is the only key we have provided so far, let's go ahead and use it here. Naturally, we'd use different keys in different situations where we needed a different string sent back. Okay, so let's save our changes, open up our terminals, and use curl to test our endpoint. First, without passing any headers. And we received hello just as we could have expected. Great. Especially since we have set up a default language in our application, and it returns the English translations for us automatically. Now let's specify the accept language header, setting PL or Polish for the value. And voila, there we have it. Cześć got returned back to us. If we change the header to EN or English, we'll receive hello again. As we can see, not only can users now pass in their desired language, if we forgot to do so, we even have our default all set up and working properly. Great. So before we wrap up this lesson, we'd like to demonstrate how you could also enhance your I18N module to let you pass arguments to translations. This essentially adds support for parameterized strings. Also, we'll dive into how you can have grouped, aka nested translations. Both of these will come in handy in your future internationalized applications. Let's start by first opening our en.json file and modifying the hello translation to be hello, first name surrounded by curly braces. These braces indicate that we're going to be inserting a variable or parameterized string here. Similarly, let's do the same thing in our pl.json file. With our translation files updated, let's navigate to our I18N service and add a new spread parameter to the translate method signature, calling it args. We'll pass these args, or arguments, to the format function exported from the string format package that we installed at the beginning of this lesson. Let's save our changes and navigate to our app service now. And for the second argument of our translate method, let's pass an object setting first name to an arbitrary name, let's say Camille. Once again, let's save our changes, open up our terminals, and let's test our endpoint once again. And voila! Hello, Camille. If we test Polish, we'll see we get back Cześć Camille, and if we set the language header to English, we'll see once again, hello Camille. Perfect, everything's working great. Although our example is simplified here, the same logic and setup could be applied in any other situation where you need to have dynamic parameterized string values sent, whether it's a specific error code that you're returning or anything else. For our last demonstration, let's implement translation grouping. For this, let's navigate to our en.json file and add the following entry. Similarly, let's do the same thing in the pl.json file. Next up, let's navigate to our i18n service, and as we can see, we're already getting some type errors now. The reason for these errors is that now our translations are not flat. Some keys might be equal to objects, not just strings as before. Thankfully, TypeScript is helping us prevent errors here that we should have expected ourselves. So to fix all of this up, let's replace the current implementation of our text variable with the following code that can be found below the course video as always. Now with this in place, i18n service consumers will be able to pass the translation key using the dot notation. For example, errors.usernotfound in our case. Lastly, we have to update the type of the key argument as well, as it right now does not support passing strings with this dot notation. For this, we'll declare two helper types above our class. Note that, like always, you can find this code to copy-paste below the course video. We won't be diving into these types as they're somewhat outside of the scope of this lesson, but just so that you're aware, combined, these types let us construct a type that consists of a union of all the keys of an object, including nested objects. Don't worry, we'll see everything in action here in a moment. Using these types now, let's update our translate method signature as follows. Let's save our changes, navigate to our app service, and remove the hello argument and see what keys we can pass in. And there we have it. Now our keys are strongly typed and fully contextually aware. We can see hello and errors.usernotfound shown here. Fantastic. Now for testing purposes, let's just temporarily use errors.usernotfound here, just so we can make sure that it works. Let's save our changes, open up our terminals, and use curl to test that endpoint one last time. And there we have it. User Camille does not exist. Great, it worked. So in this lesson, not only did we learn about an extremely important part of most enterprise applications, which is internationalization, we also learned about the power of durable providers, that unlike request scope providers, we have things stay in memory for quite some time, as opposed to being created and garbage collected on every single request. We hope you enjoyed learning more advanced concepts in Nest.js, and stay tuned for more courses coming soon. Thanks for helping support Nest.js.